Good afternoon. My name is Greg Page, obviously. I'm a technical solutions architect at Cisco. I've been working for Cisco about 11 years. My background is mainly in service provider security, but for the last 2.5 years, I've been focused on cloud and cloud technologies. So today I'm going to spend about 45 minutes with you talking about service automation and some of the complexity around that and some of the solutions to those challenges that Cisco can provide you with. But also just talk about sort of the basic building blocks as well to service automation. I'd like to keep this as interactive as possible. So if you've got any questions, please raise your hand. Be happy to take a question as we go through. If you want to have a deeper discussion later on, very happy to do so afterwards. So what are we trying to do? So most of us know what we're trying to achieve. Essentially, we have the sort of the 70-30 or the 80-20 issue or challenge, which is 80% or 70% is spent on OpEx, keeping the lights on, running data centers, and 20 or 30% is only really being invested for innovation, if you wish. And the reality is, this is legacy, this is history from sort of service-oriented architectures, silo-based build-outs of solutions, and so forth. And essentially, what we need is a new way to try to break that vertical infrastructure by building out a horizontal platform, if you wish. So we want to try to readdress the balance, essentially, between OpEx and expenditure and investment in innovation, making the business more effective in the marketplace. So also, by doing this, what we want to be able to do is be able to consume and churn services more quickly. If you look at the history of IT, you see, the adoption of radio, the adoption of television, the adoption of the iPod, and then finally, the adoption of services like Facebook. And you see this exponential, change in the adoption of those kind of technologies and services. So we need to build an infrastructure that is agile enough to cope with that change as well. So I think you saw this slide probably a bit earlier today. So essentially, Cisco has a 3-pillar strategy to cloud, effectively. First of all, it's about building technologies and integrating them into various products. Obviously, those technologies now need to be open standards, open source as much as possible. And Cisco is making great efforts towards that direction. I'll be talking about that a bit later. But also, through technology evolution of virtualization and so forth, the actual implementation of various technologies and capabilities is changing. And we get a lot more choices in what we can do. Now, that's a good thing. It's also a bad thing. Okay? Because at the end of the day, what we're really dealing with here is a lot of complexity. And we want to try to manage that complexity easily and efficiently as possible, i.e. at the lowest cost. The middle pillar here really is talking about partnership. And there's really 2 types of partnership. First of all, there's sort of a best-of-breed partnership in terms of OEMs, in terms of software, hardware solutions. So Cisco is not trying to sell you a full stack of software. You must have this storage, you must have this compute. We're actually saying, look, you're the customer, you decide what's best for you. We'll help you build that together. And the other part of the strategy here, the partnership strategy, is a go-to-market strategy. In effect, we have an indirect market strategy. So we would, in effect, utilize systems integrators and service providers to reach the end customer. We are at the moment, in terms of infrastructure as a service and so forth, we are not building out that capability within Cisco to reach out directly to the customer. So a bit more around my background is actually working with systems integrators and service providers. I've done that for the last 2.5 years in terms of building our infrastructure as a service, and we've learned quite a few lessons from that, actually. And the final piece is really covering sort of areas that you've already been listening about today. The VXI initiative that Stacy was talking about, and Steve Ramsey was talking about hosted collaboration services earlier. So it's about building services that could be resold to the end customer, that could utilize the platform, a common platform underneath. So we have this vision at Cisco to build out what we call a scale-out horizontal platform, as opposed to the more traditional scale-up capabilities. So for those, some people use these phrases sometimes, and I think, what are they going on about? So, and obviously, essentially in the past, if you want more performance and capability, you would add more memory, more CPUs to the compute node itself. And essentially, we're going through this change now where we can actually, by changing the types of applications, how we deploy applications and rewriting applications, be able to take advantage of scale-out horizontal architectures. So if you look at software like MapReduce type software, so when you do a Google search, for example, you type in the search, it goes to a sort of a lead node, and that node will then map out that request to many different machines holding parts of that database, and we reduce back that answer to the node and push back to the web presentation layer to the customer, for example. So that's an example of sort of a horizontal scaling or scale out versus your scale up capabilities. So we have this vision around a unified service delivery platform, essentially. It's building this horizontal platform that not just extends within the data center, but joins the data center with the wide area network and beyond as well, into the mobile network and so forth. So we can actually provide that end-to-end SLA that so many customers require. There are lots of different cloud services out there today. You look at Amazon, for example, most popular, most well-known, EC2 and S3 services for storage. Essentially, these services are accessed over the internet, an uncontrolled space between you and that cloud. So Cisco firmly believes that to be able to provide that end-to-end SLA, the network becomes absolutely critical to that. In effect, it works like this sort of autonomic nervous system of the human body. It's basically got presence everywhere, and it's constantly monitoring, seeing adds, removes, changes on that infrastructure wide. And if you have the right tools and capabilities and operational methodologies, you'll be able to control and manage that environment much more efficiently. So essentially, unified service delivery brings together the best technologies that Cisco has in the data center, and marries that with the best of the technologies that we have in the wide area network space as well. So just a few more points on that. So in terms of actually providing that unified service delivery, we are moving towards a virtualized world. And as I mentioned before, we have many different methods in terms of deployments, types of virtual physical machines and so forth, virtual apps, etc. And the ability to actually manage that complexity is key. So Cisco is building systems and capabilities into the network fabric, which I call sort of intelligent services fabric. The ability to do policy-based traffic steering in the actual network fabric itself. In other words, the ability to actually take a traffic flow and earmark that with a policy and redirect it via a number of different control points, for example, in the network, such things as firewalls, intrusion protection, load balancing, whatever you may be, and actually dynamically build these service chains on the fly based on policy. In the past, we were very stuck with very sort of rudimentary, very static configurations in the network, policy-based routing, WCCP, lots of acronyms I can throw at you in terms of trying to steer this traffic. And every time you try it, and I've done it in the past, believe me, it gets really difficult, and trying to manage that complexity over time just gets worse and worse. So introducing intelligence into the network is absolutely key. And an example of that would be Virtual Network Link, okay, or VN Link that Cisco has. The ability to connect a virtual machine logically to the physical network itself is a real step forward in terms of technology. And this has manifested itself in a couple of solutions that Cisco has. But the ability to actually move that virtual machine now, if we can couple it with the network and have the understanding of where that virtual machine and what it needs in terms of policy, and that policy it migrates with that virtual machine when it moves from point A to point B, then we maintain that SLA and maintain that control. So those are just some examples where, in my security days, we always had this maxim, you have to have visibility in order to have the control, okay? And if you don't have visibility, you don't have control. And that's what we're providing you with. It's both the tools and methodologies to get that visibility, and that translates into actually having control. So you saw a slide earlier from Josh, talks about the journey. And it's very much a journey. It's not a sort of big change as such. But we want to build our capabilities and build our sophistication in terms of the service offering that we're providing. And that's a multi-step journey. So virtualization is the first key point, and that's by no means an easy step. Okay? The ability to actually translate old or convert older applications and services onto a virtualized infrastructure, maybe a VMware infrastructure, or it may be another sort of Zen or Citrix or whatever it may be, and actually be able to manage that with the proper tools and processes that allows us to maintain business continuity with proper DR capabilities and so forth is the main challenge. And our partners like VMware are working very hard to deliver that capability. And you'll see in the next release of their services and capabilities that they will deliver more DR mission-critical service support, if you wish. And turning IT into a service is absolutely critical here. So a lot of service assurance tools that were built, say 5 or 10 years ago, are now coming a bit more out of date now with this horizontal concept. Essentially, these tools were built around, multi-domain, single domain support. So maybe a network, maybe a data center, maybe compute, maybe storage, whatever it may be. And what we lack there is a single service model, effectively, that is multi-domain. So there's a new breed of companies out there, so some of them are Cisco partners, that can actually provide you with these tool sets to have that single service model, both from a service assurance point of view, but also from a service deployment, provisioning, or activation, depending on how you want to cut it. Just a word on service activation. A lot of people think about speed. A lot of people think about scale. Both absolutely valid. It's really about reducing the cost of change effectively in the data center and on the network. But it's also about modeling complexity as well. If we can model complexity once, we can repeat that complicated workflow multiple times if you wish. So actually de-risks change within the business as well, once you've modeled that change. Okay, so that's a really important point. So there is a sort of a natural threshold here where traditional IT teams, processes, organizational structures and so forth will start to break down as you start to scale up and speed up some of these environments. So let's talk about some of that complexity. So we talk about multi-tenancy for a long time in software. That's a given. Multi-tenancy in the physical world in terms of infrastructure is a fairly new thing. Okay. Now, particularly in public sector, this causes all sorts of heart palpitations if you're mixing up certain information assurance levels and so forth. What we're trying to do here is provide, if you wish, a multi-tenancy and secure multi-tenancy, if you wish. So we can actually divide a infrastructure, if you wish, into multiple virtual data centers, if you want to call it, which contain service chains within themselves. So from a customer perspective, from an operational lifecycle management of their infrastructure, can actually see their own sort of data center, from the router to the aggregation layer to the access layer, switching down into the compute and storage layers as well, with all the relevant security services and so forth embedded as well. The challenge is, how do I build an operational methodology to be able to deal with some of this complexity? So, as I said, we've been working on this for the last couple of years, and we've learned some lessons very rapidly. So the first initial ideas was around this concept of network containers. And a network container is basically a XML document that describes a constrained set of resources. And those constrained set of resources can be described in both a quantitative and a qualitative way. What I mean by that is, from a quantitative perspective, it could be a number of VLANs, a number of physical machines, or a number of VMs, et cetera, But also from a qualitative perspective, you can talk about QoS and security policies and so on and so forth. And what we want to do is try to capture that in a structured way so we can actually provide that structured deployment model in situ. Now, that works, but what we've actually found is the end customers are saying, you know what, I don't build my data center in a silver, bronze, gold way, Mr. Provider. I actually want to build it my way. Okay, so now we've got a dilemma. Now we've got a dilemma between building flexibility from a customer point of view and having the standardization from a provider point of view, where we can get some of our cost savings. So we need to think about new ways to deploy the end-to-end infrastructure. So in the past, we've relied very much on sort of scripting-based techniques. The trouble with scripting-based techniques is that it's very linear in its progression, and it ties together effectively all the critical elements. So it ties together, for example, the infrastructure to execution logic to workflow. Okay? And if you want to change one of those three components, you're better off just ripping up your script and starting again. The analogy I came up with, with a colleague of mine is just, it's like building a brick wall, effectively, Lego brick wall. Obviously, copyright over Lego, but you have to build that brick wall, and if you sort of super glue all those components together with the script, it's very difficult to remove one of those bricks and replace it with something else. So the new way of doing things is just taking what we've always done in not always done, for quite a long time now in programming, which is a programmatic object-orientated methodology. Okay. The idea here is that we provide a loose coupling between infrastructure, maybe logical, virtual, execution logic, i.e. contained within an object, and workflow, linking those objects together. So we can actually represent all the components of the service chain of VRF, the VLAN, virtual machine and so forth, as objects within a model. And then we can provide additional metadata to create the meta model on how we can join those components together, those objects together. So essentially, Cisco made an acquisition company called Linesider not too long ago. The product's called Overdrive. And essentially, it does exactly this. It is a meta model for the infrastructure. So initially, we're focusing on network and network services. When I talk about network services, I mean things like load balancing, firewalls, and so forth. But eventually, you could, we'll extend this to compute and storage, etc., to be confirmed. Okay. So essentially, what we have, if you look at the slide, what we're trying to do with this meta model, effectively, is to combine at the top end, is essentially the governance model. Okay. We combine that with the cloud operational model, which is the left-hand side representation. And on the right is what you have, okay? So the cloud operational model would say, this is how I would define a tenant, how I define a virtual data center, for example, or a network container for another name, okay? Is subjected to a governance model for the business. And the topology and infrastructure assets and capabilities are there and understood as well by the tool, by the model. So the combination of the three things allows us to have flexibility in terms of how we deploy services, along with the intelligent fabric services I was talking about earlier, or services fabric. But also gives you, if you wish, the standardization, albeit standardization at a lower common denominator, more sort of atomic level. So Cisco is now taking this to the open source community as well. Who here has heard of Openstack? 1, 2, 3. Okay. So Openstack essentially is an open source movement that lots of different vendors are participating, and Cisco's now embraced Openstack in a big way as well. The idea is Openstack was originally founded by NASA and Rackspace. Okay, so NASA had a project called Nebula, and Rackspace has their own capabilities as a hosting provider anyway. And they combined forces to start Openstack. And the idea is to have this open source system, a set of tools, if you wish, that allows you to build service automation, service assurance. So what we've done is actually the last design summit, which happened in the last week of April in San Diego, was to propose a couple of things. Okay? And we proposed what they describe as a blueprint. It's called Network as a Service. And essentially, it's two things, really. So one is the sort of this abstraction layer I was just talking about, okay, with the Overdrive product. Think of it as like a hypervisor for the network and network services, okay. But also the operational methodology of network containers that I mentioned before. So now we can flexibly build those network containers through this abstraction meta model as well. What this actually means in the end is that we're providing that customer with the capability eventually, okay, when we build the tools, is essentially provide them with a canvas, if you wish, to drag and drop services that they wish to have in a certain order and certain capability with certain rules in them. And that translates into a blueprint specific to that customer. And because we have this meta model abstraction capability, we can translate that blueprint to actually laying down the actual service on the physical virtual infrastructure itself. Okay? And I can't emphasize enough that we're building capabilities around bringing together that physical and virtual environment. You cannot do one without the other. We live in the physical world. A lot of times people just talk about virtualization as the panacea to everything, but it's not. You have to deal with the physical infrastructure as well. So this has proved to be very popular, would you believe? And even the compute and the storage guys have gone, hey, that's cool. Let's take that on. You know? Let's work with that, because we can then describe what we need from compute and storage, not just the network and network services with a network container and methodology. So this is really, so we have this, we have a single model that allows us to implement the end-to-end service chain. Obviously, the constraint here is building out the model. Okay, so we are now building out, more and more capability to that model, with different iterations of deployment methodologies and so on and so forth of various services. So by the end of this year, we hope to be able to provide a full-based, RESTful-based API northbound of the tool that allows us to integrate to third-party IT orchestration, runbook automation type tools. Okay. So just any questions on that one? Fairly straightforward. Okay. So I just wanted to talk about unified compute system. Just for a second. Obviously, unified compute as a concept was, came up about 6-7 years ago by a few people who've, now at Cisco started up a company called Nova. And essentially, they were looking at, the changes that was going to occur in the data center with the impact of virtualization. And they recognized these changes very early on. So actually, this abstraction capability I've been talking about, this meta model, object-based meta model, it's already built into the management of UCS. UCS in itself has that single data model driving all the physical aspects of that infrastructure. So it represents a single XML northbound, XML API, that can drive all the physical deployment of that infrastructure. And that infrastructure, more importantly, is stateless. So we can program that physical infrastructure when and if needed. Again, improving speed, agility, and reducing the cost of change. And there's a lot of third parties out there who integrate with our XML API. Everyone from Oracle, for example, to Microsoft, to BMC software, to Computer Associates. Why? Because it's so easy to import the schema for this XML interface. Okay, it's object orientated. So it's quite it's quite a structured object model, okay? Because within the boundaries of a unified compute system, you have switching layer, you've got chassis, you've got blades, and it's in a pretty nice structured way. Obviously, when you start deploying services in the data center service chain with virtual or physical components, there are a lot more variations on the theme. Okay, so it's a less structured, more dynamic meta model, if you wish, in the things I was talking about a bit earlier, the Overdrive capability. So this is all great. So we're having this abstraction capability, gives us a lot more flexibility in how we deploy services on our infrastructure end to end. We still need capabilities around how we capture a customer order, how we translate that customer order into a service or technical assets that we can deploy against that request. So Cisco has come up with a whole bunch of tools, capabilities. Now, if you look at the slide, and I apologize for the colors have slightly changed here. But essentially, the top half, you've got your sort of service management, okay, is represented by the top here, by this rectangle. And at the bottom, you've got your resource management layer, okay, where your traditional element managers and so forth will fit. And what we've done here is show the different sort of functional areas that you require in order to run service automation, okay, of your infrastructure. So you can see that we have IT orchestration engines, we have business process management tools, We have even what we call the front office. Okay, so NewScale is a company we've acquired. That's class leading in what it does in terms of providing bespoke customer portals with bespoke service catalogs and so forth. And we built a lot of the best practices and workflow that sits underneath all this, so you could actually deploy 80% of capabilities very quickly and rapidly. And obviously, you'll probably need to, typically rule of thumb, to have some sort of services to build some bespoke around 20 to 30% of use cases. Are there any questions on this one? Can anyone see? Okay, so we're talking about automation of compute, network services, storage, physical and virtual. So let's give an example of that. Okay, it's just intelligent automation for cloud. Here we have the front office piece, the service catalog. The customer is accessing this from the web. They will then select, put their details of who they are, select the service type that they need, certain size of virtual machine with this amount of memory. It might have a certain operating system on it, et cetera, et cetera. We capture this order, and then we just hit the service request button. Service request button does a web call to our enterprise orchestration capability, this is the runbook automation capability, to invoke a workflow. So this, first of all, what we'll do is take that service request and do a high-level analysis of it. So now we're looking at the service request information artifacts. I'll call it information artifacts because it's a result of that service request from the customer. So I'm making a high-level decision now what to do. Am I adding a new service? Am I deleting a service? Am I changing a service? Pretty straightforward stuff. In this example, we are adding a service. We're actually adding a virtual machine. That in itself would then initiate a child workflow. And that child workflow would be the more sort of IT-orientated piece, which is now looking at so we're updating the portal all the time. We're letting the customer know, hey, something's happening. We're doing something for you. Please don't go away. Please don't hit go again. Please don't hit send again. Okay. We're looking at the detail now of the service request. So first of all, what we need to do is figure out, do we have the capacity and capability to actually deploy the service? And in doing so, we can actually start applying those capabilities, IP addresses, et cetera, DNS services, et cetera. There's a lot of things to think about when deploying just even a simple virtual machine. I think when we initially modeled some of this workflow, it was like 83 different steps to do this. And essentially, we can see what's going on as we go through the workflow. And by automating this, we get benefits of audit trails and things like this. But also, we can see where in the workflow things are not happening correctly. We're not getting the correct responses and so forth. So it helps with the initial build and troubleshooting as well. The idea is so that flows right through to deploying to third-party systems, talking to vCloud Direct or something with VMware, or just vCenter or something like that, to deploy the virtual machine. We're updating, the portal again, et cetera, et cetera. So you get the general idea. Okay, so this is a programmatic orchestration tool. We're not doing any coding here. Okay, that's really important. All we're doing is reusing existing adapters, sometimes called connectors, sometimes called plugins, sometimes called APIs. Okay, where we have RESTful or SOAP or other reusable type adapters, and all we're doing to talk to a third party, we are simply putting in the set of variables and attributes enable us to do that. Okay, so it's not programming; it's simply a sort of a template capability. And actually, you can actually build your own templates and so forth as well, and add that to the tool. So, what we end up with is this capability, this software stack. So you get a couple of choices really. So on the left-hand side is open ecosystem. And so we work with best-of-breed partners, as I said on the second slide of this presentation. And so we're working with BMC Software, for example, CA, all these guys, well-known examples, including the newer vendors like Xenos. When I was talking about service assurance, single service model, that's an example of a multi-domain service tool that you may want to have a look and consider. And they're a Cisco development partner as well. So, but also, you could also leverage with the API the benefits of the abstraction layer, the Overdrive tool that I was talking about, in both models. And on the right-hand side, we have our cloud intelligent automation solution as well. So going forward, a lot of the capabilities you've seen today will be augmented and built into the actual infrastructure. So the infrastructure itself is becoming more intelligent. Essentially what we're doing is building a system from the ground up, making it easier for yourselves to build a system from the top down, effectively. So taking the concept around unified compute system, single data model, and extending that over the infrastructure itself. But extending that in such a way that we can actually federate those abstraction layers in such a way that we're not left with some monolithic abstraction right across the infrastructure, that we can actually break up the problem and scale it. A bit like building the internet today. You don't build just a flat network for the internet. Today you build multiple tiers and so forth, and operational best practices, et cetera, to build a scale, deliver a robust infrastructure. And that's what we're doing effectively for cloud. So what we're essentially is making sure that we present APIs that allows our partners and customers to consume the value differentiation of the underlying infrastructure easier and cheaper. But we're also producing APIs that allows us, for example, to augment the behavior and the reliability and the quality of application delivery as well. So if you think about it today, a lot of applications and the network tend to be ships in the night. Okay, we have application performance management tools that can sort of sit on top of the network if you wish, start analyzing application transaction across the wide area network, start doing compression, start doing all sorts of tricks to reduce the amount of payload, et cetera, across the wide area network through caching, dynamic caching, et cetera. But they're still sitting on top of the network. So what we've been doing, for example, as an example, is following something IETF ALTO, ALTO, application layer transportation optimization. And we've actually implemented that on our platforms, routing platforms called Network Positioning System, NPS. Think of it as like a global positioning system for the network and network services. So the idea, for example, if you want to request some content, either from a content delivery network or from a peer-to-peer network, I can actually ask the network via this API, which acts like an oracle. I say, excuse me, Mr. Network, who would you prefer me to download this content? Because I can download it from 5 different peers. I actually will respond and say, you know what? I would like, the network would say, I would like you to, here's the ordered list. Download from peer 2, peer 5, et cetera. And the idea is that the network knows the locality, the proximity of that content much better than the application. The application, you don't have to write bespoke code to do round trip times, all this kind of business. They can just talk to one API. So the essential benefit is that the provider wins because they could provide local sources, proximity, locality of content, maybe video, static content to be delivered, and save, for example, on transmission costs, okay, with their links to other providers. But also they can do real-time modeling in terms of utilizing network management systems to optimize the best path, from a uptime availability SLA perspective. So, worst case scenario happens, if we have a node failure, multi-node failure, et cetera, we can still support the service. So I can actually traffic engineer that connection like a video from point A to point B over the least utilized paths, for example, in my network. So the network provider benefits because they can utilize their infrastructure better, save costs, but also the customer who's downloading that customer and the application itself is getting a better quality of user experience because it would guarantee the better delivery. So I'll just give you some ideas there of how we're bringing together applications and the underlying infrastructure, and how we can help you operationalize automation in the data center, but not just the data across the wide area network as well, and bring that all together. So Cisco is helping you in terms of delivering additional, consuming the value of the infrastructure. It's helping you in terms of making it easier for you to build and deliver these systems as well. So I've kind of run through the presentation fairly quickly. Are there any questions? Was that useful to you? Is it interesting? Be happy to discuss any sort of details with you afterwards if you wish to. I'll hang around for a little while and be very happy to have that conversation. So thank you very much for your time today.
Great. Thank you, Greg.
No problem. Okay, thanks.
So I'll make sure.